the way I describe latent heat of vaporization to people, we've all been putting hand sanitizer on ourselves since at least 2020, right? Some people were ahead of the game, but we were all forced to. But you feel that alcohol vaporizing on your hands, right? You feel how cold they get, and that's just a really good real world example of the cooling effects of alcohol based fuels.
Welcome to the HPA Tuned In podcast. I'm Andre, your host, and in this episode, we're joined by Zach Denney, North American distributor for ECUMaster. The ECUMaster brand is one that got on our radar a few years ago, and it's gathered steam, particularly in the US market and here in New Zealand and Australia, as a great product that offers a really great feature set, particularly when you take into account the price point. We've previously installed the ECUMaster PMU Black in our Subaru Vision 11 STI and created some course content and webinar content using it. So it's a product I know reasonably well. We're also using ECUmaster's PMU 16, or specifically two of them, in our Toyota 86 race car, even though we're actually using a competitor's brand of ECU and dash in that car. We'll talk about some of the integration with these electronics as we go through this chat with Zach. Before diving into ECUmaster, we find out about Zach's background, how he built up his skill set with mechanical knowledge as well as tuning knowledge, and how he took the leap of faith and became the North American distributor of ECUmaster, and how he grew that business from selling ECUs out of his bedroom to now what is a fully fledged aftermarket parts company. Before we get into our interview with Zach, for those who have maybe been hiding under a rock and this is your first episode of Tuned In, High Performance Academy is an online training school. We specialize in teaching people how to tune EFI, how to build performance engines, how to build wiring harnesses. We also cover race driver education, race car setup, and data analysis, just to name a few topics. All of our courses are delivered via online video-based modules that you can take from anywhere in the world, provided you've got an internet connection. As an added bonus for our podcast listeners, you can also use the coupon code podcast75. That'll get you $75 off the purchase of your very first HPA course. Now, we'll put a link to that coupon code in the show notes, plus a link to hpacademy.com/courses, where you can find a full list of all of the courses we currently offer. All right, enough with our introduction. Let's get into our interview now. All right, welcome to the podcast, Zach. Thanks for joining us today. And as always, we're going to get started by finding out a little bit about your background. So let us know, for a start, how you got interested in cars.
Yeah, blame my dad for that one. He always had a subscription to Road and Track, and I think for a while, maybe Motor Trend or Car and Driver, but definitely remember reading Road and Track, and especially like Peter Egan, who's a great automotive journalist and a storyteller. And we always had, kind of one classic car in various states of disrepair kicking around the house. So kind of a natural thing to fall into.
Were you actually involved in tinkering on these cars yourself? What sort of skill set did you build up over that time, and how did that interest and passion for cars kind of develop?
Yeah, so most of the older stuff my dad had around were kind of mothballed, so we didn't really work on them much. But we always had kind of, I don't want to be impolite to my parents, but our daily drivers were always had a little character, and so it was more just jumping in and helping with that. And I remember in high school, you put a quart of oil in the Corolla every day, and we didn't know if it leaked or burned it. And back then, oil was actually more expensive than gas. It was like $1.50 a quart and about $1 a gallon for fuel. So you just put a quart in, and it spit out whatever it didn't want. There was always something to work on in the house, just keeping the fleet going. So it was kind of a natural thing. And then did auto tech in high school, bought a 1990 Supra as my first car that, of course, blew a head gasket shortly thereafter, as 7Ms did.
Yes, they're quite well known for that. However, if you fix that one obvious weakness with them, actually a really great engine.
In a lot of ways, yeah. I just got really sick of scraping paper gaskets. And, there's 3 accessory belts.
This is before the time of pretty much any performance engine. These days, obviously, MLS gaskets are kind of the go-to even for the OEs, but this was a composite style gasket, so not well suited to a turbocharged engine, are they?
No, and so it was just, a lot of lines everywhere, and it's kind of just messy and cluttered. And if I knew then what I know now, I could have, cleaned it up and really done a lot with the 7M. And I pursued it as far as I wanted to go until when I was in college. I started working at a super shop and working on JZs every day, and just kind of opened my eyes to how kind of easy that motor was out of the box. And so I put a 1JZ in the car.
Yeah, I mean, definitely. If you're comparing a 2JZ to a 7M, there's no competition. It's 2J every day.
Yeah, it's just a generational gap. They're much easier to work on, much easier to service. And that was a lot of the appeal was by the time you do an aftermarket intake manifold and all the other stuff on a 7M, then one JZ swap is cheap in comparison. So I went that route.
Yeah, absolutely. So you're working at a shop dealing with these Supras. Are you doing an apprenticeship? You mentioned Autotech in high school. Yeah, are you sort of going down the mechanic path at this point?
Kind of. So yeah, I started, my first job was a discount tire before I could even drive. So I started changing tires. And that was when I was in Autotech, and then went to college, still worked at the tire store, and then did a couple years of engineering school, was not great at it. And so I, took a break from school for a little while. And that's when I got the job working at the shop that specialized in buying and selling and working on Toyota Supras. And so, yeah, I've probably driven and worked on, well into 3 digits of Mark IV Supras. Got very familiar with that platform, and, eventually spun off and started my own little workshop, just doing a couple things here and there as I went back to school. Didn't do much there, and then worked at an MR2 shop called ATS Racing and learned more about the tuning side of things there because they did a lot of dyno tuning and, a lot of turbo setups and motor builds. And that really expanded my skill set quite a bit working there.
Am I safe to assume here we're talking the later generation SW20 MR2 chassis?
Yeah, mostly SW20s. We did a few AW11s. I think the favorite car I've ever worked on was a kind of a ratty AW11 that we put an HKS stroker 3S GTE. It was kind of an unknown motor we got from an importer that had like an old school Greddy T78 on it. And of course, it had a Power FC because that's what they all had. And it ended up making like 530 at the wheels.
It's a hell of a lot of power for a very small chassis.
Yeah, and it had like this little 180, BF Goodrich was like the only small drag radial on the market back then. So these little like 185 or 205 baby drag radials, it was like driving a Sharpie. I mean, at will in the first 3 gears, you just mat the throttle and leave black marks. It was absolutely a ton of fun.
Yeah, actually, you're taking me back to my youth there because I had an AW11 supercharged MR2 with the 4A GZE factory engine in it, and that was actually my daily driver for a good few years, and I absolutely loved that car. I would have another in a heartbeat, but unfortunately, as anyone into Toyotas know, Toyotas of that era, one thing they do exceptionally well is rust to pieces. So very difficult to find a clean rust-free example, particularly here in New Zealand, and keep them alive. But cool little chassis. It's interesting as well. You talk about this shop and the Supra shop. Obviously, the US market is massive in comparison to here in New Zealand. But if I compare this to my own shop, if I had run my performance shop here in New Zealand and based myself exclusively on one model of car, be that Evo, Supra or whatever, I wouldn't have been putting food on the table, never mind being able to pay my staff. You just had to be able to adapt to a broad range of different platforms because the country's so small, whereas I guess in the US you've got all of these popular platforms. There's hundreds of thousands of customers all around the US who have them, so you can specialize. In terms of that, do you see that specialization as, how do you weigh up specializing in one brand versus having experience, but maybe not the depth of experience across a wide range of different brands?
I mean, I think there's huge benefits to specializing in one platform because you know exactly what a job's going to take. You know what all the pitfalls are, the common problems. It's easier for the shop to budget and train staff for it and control the product where, it's really hard to make money. I think every performance shop you've ever been into has that one nightmare project stuffed in the corner somewhere, right?
Absolutely.
And it's because the shop, they either took on a customer they shouldn't have, or the customer didn't know what they wanted, they got in over their head on a platform or into a problem they couldn't solve. And I think you eliminate that by specializing in one platform. And I think the best solution is to offer packages to customers. Don't let them bring in all these secondhand piecemeal parts. Say, hey, look, we know we can deliver on this package and offer you this at this set price, assuming all the other parts of the car are in good condition. But, people get in over their heads bringing somebody kind of a pile of junk and toss it on the dyno. Oh, it just needs tuning, right? We've heard that.
Yeah.
How many times?
I couldn't agree more. This is probably a good time. We'll sort of go down this rabbit hole a little way, and this is probably more angled towards the business advice side of things, or at least business experience that I'll share. Because what you're saying is just resonating really with me on how my old shop went. And as I mentioned, we sort of were in a situation where we were forced to a degree to basically cover a wide range of different models. And we did get into that situation. We were dealing predominantly, I guess, with that younger market. It was predominantly here in New Zealand, JDM. That was what we were known for. We specialised in Evo here, but you kind of had to do everything. There's actually not that many Evos in New Zealand. And because we're dealing with this younger clientele, it's hard to pigeonhole younger enthusiasts. So don't be offended if you feel like I'm talking to you while you're listening. But a lot of them had what I'd say champagne dreams and beer budgets, but probably spent the majority of their budget, if not more than they had, on the purchase of the car. So when it comes to upkeep and modifications, there's no money left. So often I was dealing with cars exactly as you mentioned there, just needs a tune, and you get it in, and you don't even have to bolt it onto the dyno, and you realize that this thing needs about 8 to 20 hours of workshop labor just to get it in a position where it can be tuned. That never really goes that well, and also messes with your time frame. Later, I think we got a bit smarter, and I guess we went kind of more down that one mark sort of direction, and exactly what you mentioned again. I think it's really worth reiterating. Packages. We were dealing with the Australian domestic market, Holden Commodore and HSV, very similar to your sort of Pontiac GT, I think it is, G8, sorry, LS based anyway. And long story short, we basically developed these packages. We're dealing with a higher price point car. You're generally an older clientele customer. They've got a bit more disposable income. We offered these packages where it was exhaust headers, intake, reflash, or staged upgrades beyond that. We knew almost within the kilowatt what the end result was going to be once we'd finished. And because it was repetitive work, my techs got really good at fitting the parts. And that was really something that turned the game around. So I just wanted to double down on that while you mention it, because I know we do have business owners listen to this as well as enthusiasts, but we will move on. So at this point, you're at this MR2 based specialist shop, and then you mentioned you started your own shop. So tell us a little bit about how that went.
Yeah, it didn't go well.
Okay. Yeah.
I mean, I was young and I didn't have any money. I went to work. I actually sold Toyotas for about 8 months at a dealership, and I had a little bit of spare time there, and I rented a shop space, and for a while I thought I might get into doing like kind of custom powder coating along with just some a little bit of work here and there on Supras. I didn't want to step on toes with the guy I used to work for, but yeah, it didn't go that well, and I was taking some junior college courses, so it was kind of figuring out what I was going to do without a ton of overhead, and yeah, it didn't go great. It's hard to start a business without any money, as it turns out.
Yes, yeah. Bootstrapping it is possible, but definitely it's a difficult way.
Yeah. And so you got out of that and really focused more on going back to school. But, when I was working for ATS Racing, I took a welding class at local community college. They let me skip all the MIG courses that were kind of the prerequisites, because I showed them, said, hey, look, I got basic competence with a MIG, but I'm never going to use that in motorsport, truthfully. Like, predominantly TIG. And so I got pretty good at that and just really tried to keep adding on skill sets and learn things more, because I want to do stuff with my own car, which it's tough to find the energy to do that when you're working on everybody else's car all day. But, really kind of building block one at a time, learn the different skill sets in the shop. And, I got to peek over the shoulder and get a little help tuning my own car, which, 1GZ on a Power FC. And that was kind of it was a fun learning experience, but obviously we're spoiled with how good the hardware is now, but it was nice to learn in pulse width.
Yeah, we dealt with a lot of Japanese imports here in New Zealand, and predominantly that ECU of choice was the Power FC. And I mean, I'll be honest, in the day, provided you had like the FC data logit software so you could actually do it on a laptop rather than that horrible hand controller, it's not a bad product. It does a pretty good job.
Yeah, and Aaron at ATS, he showed me a trick where you could copy and paste the data from an Excel spreadsheet, do the weighted average of a cell, copy and paste that over and basically use that as a manual long-term trim, right? You'd log the data in a bunch of different cells, and we just had an inertial dyno, so I just drove around on the street a bunch and got it dialed in. But that was when ethanol was becoming available, and I was learning, how inconsistent those blends were at the pump, and then you had to go retune your car every time you filled it up, and I'd have 5 different maps I could load based on what kind of spitting range the ethanol percentage was.
No flex fuel capability on the Power FC, unless I've missed something dramatic.
No, there's nothing. And I dreamed up a device where, I never got around to constructing it, but I was going to use the air temp input and modify an analog signal to the air temp input and change that scaling in the Power FC as an ethanol content input, just basically use it as a global trim.
Sure. So basically a Band-Aid fix for this problem. Let's talk a little bit about that. So I think, ethanol at the pump, E85 mix has really changed the game, and there's a lot of tuners coming through these days, and I've talked about this on the pod before, who have never really been exposed to shitty grades of pump gas where knock is a massive problem, and all power to them, but they haven't actually seen how hard tuning can be when you are forced to run pump gas. So it has changed the game in terms of power capability, keeping engines alive, safety, etc. But we talk about this E85 blend and pump E85 versus a race grade E85 where that ethanol content is very, very controlled strictly. You expect if you're putting E85 at the pump into your tank, then it is E85. But from my understanding, I think the specification actually allows down to about E56. I could be slightly off the mark there as a winter blend.
And the max is, I think, somewhere around 82. It's not even 85.
All right, so let's roll that back a little bit. And for a start, why is E85 or an ethanol blended fuel so advantageous for a performance application and particularly in a turbocharged vehicle?
If you put it in an octane engine, which this may be going a little too deep, where you can vary the compression of an engine, it will take more cylinder pressure to get it to detonate and have unstable combustion than a gasoline.
So if we look at that octane rating of the fuel, and every fuel has an octane rating, there's actually two. There's research octane and motor octane. I'm not going to get down the weeds with that, but essentially the higher the number, the more resistant the fuel is to spontaneous combustion or auto ignition, which leads to detonation, and that's one of the most damaging elements of any performance engine. So we get away from that. Also, the cooling properties of ethanol as well, I think worth factoring in as well.
Yeah, and that's the beauty of ethanol is that even if it took the same flow mass or mass flow rate of fuel, which it doesn't, it takes a lot more. 1-to-1, ethanol takes more energy to vaporize than gasoline does, which means that energy is coming out of the intake charge or your engine, right? So it's quite literally cooling the intake charge and whatever internal parts of your engine are anywhere in that path. So it's beneficial really from the cooling aspect as well as, if you look at the raw octane number, that's an advantage too, but the cooling effect, and then there's so much more ethanol required in terms of volume.
I think that cooling effect is one that a lot of people overlook because they're factoring in just this increase in octane. But as you mentioned there, I'll just go a little further. It's the latent heat of evaporation, which essentially is a term we don't need to worry too much, but it basically means how much energy the fuel will absorb in the form of heat as it goes through a phase change from liquid to vapor, and it absorbs that in the form of heat inside of that combustion chamber. So the factors that drive the engine's propensity to knock, one of them is the octane of the fuel, but also all other things being equal, the hotter the combustion charge, the more likely the engine is to suffer from knock. So by pulling that heat out, it gives us another safety margin. Now, you talked about the fact that the amount of fuel we need to deliver on an ethanol blend versus pump gas is different. So can you give us a little bit more insight into that side of things?
Yeah, and it's like, 10th grade stoichiometry, whenever you did chemistry, stoichiometric mix of what is pure ethanol. It's closer to like 8-to-1, isn't it? Isn't it like closer to 8 or 9-to-1?
It depends on the specific blend, but E85, like straight ethanol, actually I can't even remember off the top of my head. I normally work on E85, which I think is about 9.8-to-1 or thereabouts.
Yeah. And so whereas gasoline is, if you can even get real gasoline is, 14 and change. And so, yeah, you just have that much more fuel coming in, you take more of it. And the way I describe latent heat of vaporization to people, we've all been putting hand sanitizer on ourselves since at least 2020, right? Some people were ahead of the game, but we were all forced to hit it. But you feel that alcohol vaporizing on your hands, right? You feel how cold they get. And that's just a really good real world example of the cooling effects of, alcohol-based fuels.
Yeah, absolutely. I mean, that's a real. The other one would be if you've stick your hand out the window of your car as you're driving down the motorway and it's maybe drizzling, and that water evaporates off your hand and your hand feels cold. So it's sort of same sort of thing there. The point here is, as the stoichiometric air-fuel ratio of the fuel we're running on changes, so does, therefore, the mass of fuel that we need to deliver to match a given mass of air. And obviously the air, for all intents and purposes, is fixed. As we vary the ethanol content, though, that stoic air-fuel ratio is changing. So what that means is that the mass of fuel that we need to deliver to maintain a lambda of 1.0 is going to change. So I'm going full circle back to this. This is your point with the Power FC, no flex fuel capability. Basically, every time you go and fill up with pump ethanol, the ethanol content's varying, so you then therefore need to actually change your tune to suit. So, long way of coming back to that. That's relatively simple point, correct?
Yeah, and then before ethanol, I remember going to the street race, which of course I've never broken the law, but street racing, when back in the day when you yank the wastegate hose off a Mark IV Supra and you add a couple of gallons of toluene, you go to your local paint store and you buy toluene, and then you add a little bit of Marvel Mystery Oil to lubricate the fuel system. And that, every weekend I could tell you that smell. I mean, it's like burned in my brain. making our own homebrew race
Rocket
gas.
fuel.
Yeah, exactly. Dumping that in the tank, and then you pull the wastegate hose and you get 19, 20 pounds on stock twins. That was enough to beat basically anything on the street back in the day, the late 90s. But yeah, that was what we had before we had ethanol. If you really had money, you could put race gas in your car. But most of us were going to the paint store and getting some toluene.
Yeah, sure. I mean, for those who haven't really followed the development of the fuels that we currently have access to, that toluene that you mentioned, that was, at least as I understand it, a major component of the fuels that F1 were running back in the original turbo era. So, those guys running, I think, 4 bar or more of boost and qualifying trim. So yeah, that fuel obviously has a really good ability to withstand knock. All right, we've gone down this sort of rabbit hole a little bit. Let's get back to where you are in your career. So it sounds like at this point you've actually developed quite a wide range of skills. It sounds like you've got some basic mechanical or maybe some pretty advanced mechanical skills. You've also, as you mentioned there, picked up some tuning skills and welding as well. So what do you do next?
Yeah, so I got more serious about going back to school in my late 20s. I realized that, at a certain point I had to kind of become a grown up a little bit. I was making a few $100 a week working in shops, and that just wasn't sustainable forever. And so I spent a really brief time at kind of a road racing shop where we prepped road race cars, and that was neat, but it was basically just race prep. I mean, it was not anything very sophisticated. And then went back to school full time for engineering again at the University of North Texas and got involved in the Formula SAE program. And jumping into that, I had a lot of practical skill set and a lot of these guys in the program. And really, we had a lot of older students too, because it was a new engineering program. So you had a lot of people that were kind of making a circle back to going to college. Either they were on the GI Bill, getting out of the military, or they'd tried, working for a while, whatever the reason was. We had a lot of older students. And when I say older, I mean mid-late 20s, as well as some people straight out of high school. But it was a brand new Formula SAE program. We didn't know anything about what we were doing. We got some good mentorship from the guys at University of Texas at Arlington who've had a stellar program for decades. And then I was in charge of the whole vehicle electrical system, just because, out of the group there, I had the most experience there. And then, I helped a lot with just the actual fabrication tasks, fitting tubes and TIG welding. I didn't design any of the chassis, but the guys who designed it maybe didn't have as much practical knowledge as a couple of us that had done a lot of welding and fabrication. And so, I spent way too many hours working in the Formula SAE lab. There were weekends where I'd leave my, 2 p.m. class on a Friday and I'd work through the whole weekend, just slamming energy drinks. And I'd go to my 8 a.m. class on Monday and then just go home and pass out for 4 hours. But I worked through the whole weekend just because there was a bunch of work that needed to get done. And we made it to competition our first year, which was really remarkable to have a car that makes it through all the events the first year. And the only reason it survived, and I don't know if I should even mention what ECU we were using. I don't want to throw anybody under the bus, but it was fine. But it was a little, documentation was kind of spotty here and there. Depending on which version you had, and it was really. Ended up having to make my own custom Hall effect cam and crank triggers and a lot of machining involved, and learned the nitty gritty the hard way because nobody was going to bail me out. There wasn't like a tech support number I could call. And in competition, our endurance competition, we had a coolant leak because we'd had to repair the radiator the night before, and whoever put it in didn't tighten the clamp all the way, and so we just lost all of our coolant within the first we'll call it 5 laps of a 40-lap race.
Nice. That's a great place to start.
And I'd really built in, because I didn't trust anyone to watch gauges, right? We only had a couple of gauges in the car, and it was all very novice drivers. I was probably the most experienced driver, and I'm not a good driver, which is not saying much for our whole team. But I just ramped in a crap ton of coolant temp enrichment. So, obviously you're going to be enriched at lower temps. And then I just, added a crap ton of fuel up top.
So you're using that fuel to help cool, essentially.
Exactly. And so it was a fuel-cooled engine for the last 10 or 15 laps of this race. And, the coolant, we barely kept it running during a driver change. And we managed to finish, and we scored, we were pretty low because it was a heavy car. It was a first year team. It was overbuilt. It was kind of a tank. And we scored, probably like bottom third of the pack, if not closer to the bottom. But we were first place in fuel consumption, which is a bragging point.
Yeah, I don't know if that's the aim with fuel consumption, but anyway, you can get to the finish line.
You're on the wrong side of the world. On this side of the world, I think we get to brag about that.
Yeah, sure. I think we're sort of over a year, maybe 70 plus episodes deep on this podcast, and I'd wager probably a third of the people that I've talked to actually were involved in Formula SAE. And I've said it before on the podcast, it saddens me a little bit because I never had that opportunity at the university that I went through. But consistently this is a pivotal part in people's sort of development, and how would you rate that as in terms of importance for where you went to in your career beyond that?
It was huge. I mean, and really, it's not just, it's almost, I mean, it was one of the most difficult things I've ever done to balance that with an already challenging degree plan, right? Engineering school, if you can just make it through engineering school, you're doing really, really great. If you can do engineering school and somehow manage to keep your grades above failing and also build a Formula SE car, I mean, you're, top couple of percentile. I interned at Peterbilt, big truck manufacturer, and the chief engineer at Peterbilt he did Formula Baja, not Formula SE, but he tried to hire as many Formula SE kids as he could, just because he said they came out 3 years ahead because they'd seen a project to completion. And projects at an OEM take so long that to get the value of that, you have to stay for years in a position. And so he would snatch up every single one he could and hire them at Peterbilt just because they had so much more value than just your student that had done maybe a senior design project or something simple.
All right. Well, I think there's a key there to those listening who are maybe in college or about to embark on that adventure, that if this is something you see in your future, then probably trying to get onto a Formula SAE team would bode well for your abilities in the future. Let's fast forward a little bit. So we want to talk a bit about ECUMaster and ECUMaster USA, which you're running here today. How did we sort of fast forward from college, Peterbilt, to what you're doing now?
It was a direct transition. So I was interning at Peterbilt, trying to finish my degree. My second year on the Formula SE team, kind of had a falling out with the team because I was devoting a lot of my resources to my schooling to try to graduate. And, I was not easy to get along with because I wasn't sleeping, right? I was trying to get through school, and, it was challenging to get along as a team in good conditions, and in bad conditions, it's very hard. I was trying to
tempers tend to get a little bit frayed when people are working on a few hours of sleep. Yeah.
100%. And so I was really trying to pull back and do the electronics on the car. The second year is my senior design project, and then use that as credit to graduate. And then I had the job offer at Peterbilt. I was planning on working there, and everything kind of went to pieces. And so I lost basically what was going to be my senior design credit. And the school was small enough that it only offered that once a year. And so I was looking at a whole extra year of school. And, I saw the opportunity to distribute ECUMaster products, and I'll cover that in a second. And so I found Peterbilt a significant amount of cost savings, kind of my spare time at work. And I said, hey, how much are you going to bump my starting offer? I found you, 7 figures worth of cost savings, kind of just in my free time looking for things to do. And they wouldn't bump my starting offer. So I realized that the corporate world maybe wasn't for me in that sense, and just kind of took the jump.
Okay. So how did you have that relationship to start with? And I guess we probably need to get a high-level view of ECUMaster as a brand for a start, because they are a company based in Poland. So you're quite well removed from that. How did that relationship with ECUMaster in Poland begin?
Yeah, so again, I used an ECU on Formula SE, so I was aware of the offerings that were out there. And I remember I was on Super Forums and somebody mentioned, a piggyback from ECUMaster called the DET3. And I looked at it, I was like, it's a pretty clever little device. It can translate a frequency or an analog mass airflow signal to a map sensor. You can do speed density conversion and do a couple other trick things. And, it was a neat little device. I started looking at their website and saw they had a full standalone, and the specs looked great. Reached out to them, got some pricing information, and I mentioned it to my brother-in-law, and he kind of knew where I was in terms of my passion for cars, and he'd seen what I did for Formula SE in school, and he was a former consultant for a pretty high power consulting firm, so he had a lot of business experience, owned his own business at the time. I said, I think I can buy it for this, and I think retail it's worth about this. And he said, well, you want some money to get started? A broke college student, of course it sounds like a great idea to give up a corporate job and sharing a bedroom in a house rented with a bunch of roommates and try to make a go of things. And so he basically helped me get off the ground and ran it out of a bedroom for at least 3 years, eating a lot of ramen. And, I remember being in the Taco Bell drive-thru checking my bank balance to see what I could get off the dollar menu.
Yeah. So again, that sort of bootstrapping it with little to no money to get started. I mean, I'm going to guess that for a start, building a brand in the United States essentially from close to scratch must be pretty daunting. Yeah, at this point, and I'm not quite sure exactly what year we're talking here, but there's a lot of brands in the aftermarket ECU space, and particularly if we look at the US market, I've spent a fair bit of time over there. Products such as AEM, Haltech, maybe Motec and Cyvex are pretty prevalent, just to name a few. How did you decide that or how did you see that there was potential in developing a dealership network across the US for this, what I can only assume at the time is a relatively lesser known brand?
Yeah, and you got to remember this is 2014, so end of 2013, beginning of 2014. And if you look at the offerings on the market then, they weren't nearly as good as they are now, right? And so back then we didn't call it the EMU Classic. Now we call it the Classic, but back then it was just the EMU. In fact, there's one behind me. This box on my shelf, I keep one as kind of a little museum piece, which is still a very capable ECU. But yeah, it had 6 built-in igniter channels, so I had the IGBTs on board, 4-rotor map sensor built in, Bosch 4.2 wideband controller built in, 2 EGT inputs built in, a couple extra analog inputs, and the specs: 6 ignition drivers, 6 injector drivers. And back then, I've always been about Supras, and that was my core market. And
sounds like a perfect platform for a 6-cylinder engine.
Correct. And then also a lot of ECUs back then. I mean, you got to understand how many extra boxes it required to do all these things, right?
Yeah. Wideband on board back in 2014, that would have, if I'm stretching my memory back, but I think that was probably still quite rare. Most were still requiring, as you say, an external box, an external wideband controller, which kind of gets me into one of my pet peeves as well. I really hated dealing with wideband controllers that you interface with the ECU via an analog voltage input, because you're typically dealing with a 0 to 5 volt input, which spans your lambda or air fuel ratio range. Sometimes it's only 0 to 1 volt, which the resolution gets even worse. And then it's very, very easy and actually very difficult not to end up with a ground offset, which then renders your actual reading that the ECU is seeing almost completely non-trustworthy, correct? I mean, basically the voltage that the wideband outputs, the wideband controller outputs to the ECU, let's say that's 2.5 volts, but what the ECU actually sees might be something quite different, maybe 2.7 volts, for example. And then when you actually scale that back into lambda or air fuel ratio, obviously there's an error. And because you're seeing a number on the laptop screen, we tend to go with our gut and trust that. And it could be completely wrong. So I've seen a lot of people get into trouble with that, which is why I'm a massive advocate for either on board, where the data is integrated straight onto the PC board, it's what it should be, no ground offsets to worry about. Or alternatively, we saw a lot of ECUs go down the path of using a standalone CAN-based external wideband controller, communicating via CAN, which we're going to talk about as we go through this, and therefore the integrity of that data is also guaranteed. So yeah, getting back to the unit, does sound like it was probably a little bit ahead of the game back in 2014.
Yeah, so and I just remember 2 knock sensor inputs. There are still ECUs on the market today, and I will absolutely throw people under the bus today. If you're making an ECU that's a current offering and it doesn't have a knock sensor input, I mean, it's comical to me that that's not a fundamental requirement for offering a proper standalone these days.
Yeah, I agree. I will go a little further and say, though, I reckon that probably, I'm really taking a stab in the dark here, maybe 75-80% of ECU installations that do offer standalone knock control or built-in knock control are either not being used at all because the tuner doesn't know how they work or how to set them up, or maybe worse still, are being set up incorrectly and are hence ineffective. And the problem I see with it is people kind of think that knock control on an ECU these days is a golden ticket to not do their job properly and calibrate the ignition table correctly in the first place. So we'll just put some timing numbers in it, and if it knocks, and the knock control's going to come in and pick up the pieces. And I mean, the way I look at knock control on any ECU is it's kind of there as a bit of a safety backstop in case the car gets out in the real world. Maybe it gets a bad batch of fuel, the octane isn't what it had when it was on the dyno, maybe the temperatures, air and coolant temper just through the roof compared to what you ever saw on the dyno. It gets into this weird situation that you couldn't see on the dyno that results in knock. That's where that knock control strategy comes in and picks up the pieces, rather than constantly having the engine knocking and using that knock control to pull it back. That, in my opinion, is dangerous. The other element is these systems don't tune themselves. It requires validation in terms of the frequency that it's going to be listening to for knock. Try and improve that signal to noise ratio, because the engine mechanically is a very noisy device, and trying to actually, regardless whether you're using knock control on an ECU or you're using an audio knock device and physically listening to the engine for knock, sometimes it can be quite difficult to actually pick up that knock signal over that background noise, particularly if you've got a mechanical solid valve train, for example. Things do get quite noisy. So that process has to be done by the tuner as well. The ECU won't do that for you. That sort of match your sort of understanding or your beliefs on knock control?
Yeah, and I have a lot of very strong opinions on what ends up leaving most dyno tuning sessions, right? And it's not if customers knew what they were actually getting from a lot of tuning sessions, they probably wouldn't be willing to go back to a lot of people, right? And the problem is, I think we've set a false expectation of how much time really needs to go into tuning a car.
I couldn't agree more with that, because that was the next point I was going to make. You take your car to a tuner, and whatever the cost of that tuner is, maybe obviously very market specific, so maybe it's $600, maybe it's $1,000, whatever that may be. You're trying to compress a lot of tunes into a day or a week to try and make a living. So you do, as a professional tuner, generally have a relatively limited time span that you get to spend with a car. And like I just mentioned, setting up knock control properly, that's going to take some time. It's not a 2-minute operation. It needs to be dealt with properly and carefully. So I would say that drives the majority of tuners simply to not bother. And I could probably count on 2 hands the number of cars that I've retuned, that have been tuned elsewhere, that have come to me with properly set up knock control. Let's take that down to 1 hand. It's just almost unheard of. More often than not, the knock control functionality in the ECU is simply shut off from the get-go. So it's just doing nothing. It's a feature that's not even being used.
And for me, this goes back to the same thing where, a good shop that can specialize in one platform, they can offer packages. They don't have to reinvent that control strategy from scratch for every car. If they're selling a known package with similar components, they don't have to go redo every part of the calibration from scratch. They really know what their cold start enrichments need to be generally. They're going to have a map that's very close generally. So, there's a lot of benefit to offering a package, because you're not having to spend 3 days dialing in the whole calibration for one vehicle under a few different whatever conditions you can replicate on the dyno, right? We don't get to change the temperature or the atmospheric pressure or the humidity unless, you have more money than an OEM. So yeah, I think that really is, again, speaks to the note of buying something, that is in a package, or learning some basic tuning. And I'll pitch High Performance Academy, right? If you learn some fundamentals yourself, you can go back and tweak the calibration as you see different conditions and you get some miles in the car. You have more time to do it yourself. But somebody who really needs to bill out at $150 an hour or more to run a profitable shop, I mean, a dealership these days, almost any dealership is going to charge $130 to $150 an hour for labor, and that's somebody who just swaps out parts generally. So for specialized skill set, it's a little silly to think we can pay somebody $500 or $600 and get a reasonable amount of their time for a very specialized job that requires a lot of work.
Yeah, definitely. And I mean, you've got to also understand that a tuning shop may have $100,000 invested in a dyno, maybe a little less, maybe quite a lot more, then often as much again in a dyno cell to actually run that dyno. And so there's a lot of sunk cost involved in tuning cars. So it's a tricky industry to really make a good living in. I'll just come back to what you mentioned about changing conditions as well, because this is, again, I think I wanted to align here those listening who are maybe getting their cars tuned professionally, just maybe align expectations with what the tuner can and can't do, because we aren't magic. I know there's this belief that tuning is some kind of magic, and straight from the get-go HPA has just been blanket like, no, there's no magic here. This is simply science. And the reality is, like, if I take back to where I was located when I was tuning professionally, we didn't have a massive swing in temperatures, and I'm sorry for the US followers, I'm going to talk in degrees C, but in the summer we might be lucky to get into the high 20s 2 days of the year, maybe low 30s. In winter we might drop down to single digits, maybe 5 degrees, maybe 3 degrees if we're really lucky, or unlucky. So not a massive swing in reality, but even so, having said that, if you get a car in the middle of summer and it's a scorching hot day, we would always have the car in overnight so that we could address the cold start conditions the next morning. And if you're only getting down to maybe 16 or 18 degrees in the morning, well, that's your starting point. You can't properly calibrate that cold start enrichment down to 0 or -5 degrees. Here, where we're based in Queenstown at the moment, in winter we will have days where we're -10, maybe -15. So I would always educate the customer and say, hey, look, we're tuning in the middle of summer here. It's possible that when we get to winter and you get a really cold day, hey, maybe your cold start's not going to be quite perfect, and I'm quite happy to bring that back in and readdress that. But that education up front, I think, is so important, because otherwise, of course, that customer gets to winter, the car's not starting very well, and the old story, it's always the tuner's fault. So just that education there. Let's talk about growing the ECUMaster brand in the US. What was your sort of process there? You mentioned you're sort of working out of a bedroom for 3 years. Were you doing direct-to-customer sales, or were you trying to build up a network of tuners on a wholesale basis as well?
It was really both. And in the beginning, I believed that I hope that our dealers would add a lot of value to the brand, and some of them have. But in general, all the responsibility for marketing the brand in the US has fallen ultimately to me, right? I can't expect a dealer to have an expensive marketing campaign or to do a lot of sponsorship deals. And really the way the whole relationship started, just to cover that, I basically sent the guys in Poland a really nice email. I said, hey, I've got some financial backing. I've got some experience in the industry. Here's this thing I've done. I studied engineering, almost graduated. I'm like 6 classes short. So maybe one of these days.
Close enough.
Yeah, it's close. So what if I didn't pass differential equations? And just pitched them on the idea and said, hey, I'd like to be your exclusive distributor for North America and handle all the marketing and support and sales. And but from the beginning, I needed the margin from retail sales to fund the growth. And really, if we're doing all of the tech support, and we do have some dealers that really do a good job of tech support, but generally, if somebody resells our ECU, nobody's going to Google the guy they bought an ECU from. They're going to Google whatever name's on the ECU and call us up. And I've always been very protective of the reputation of the brand, because I was the guy that couldn't call an ECU company to get an answer, right? And I know what it's felt like to not be able to get answers, not get help in a reasonable amount of time. And I don't want to offer a product without that really solid basis for support. And so, but that's expensive, right? And having good people on staff to do that it's a very high cost.
I think that is one of the elements when shopping for an ECU that is easy to overlook. I mean, most people are looking primarily at price, and once they've got a price point, they're then looking at a feature set that matches what they need, which totally makes sense. But it's very easy to lose track, particularly if you're doing this yourself, or actually for that matter, if you're in the market to bring on another brand as a professional tuning shop. It's very easy to overlook that you will 100% have questions that need to be answered, particularly if you're doing it professionally. You've got a car bolted to the dyno, strapped down to the dyno. You've got a question, you need an answer then and there. You can't wait 24 hours for the answer, because you've got to take the car off the dyno, waste a whole bunch of time and money so that you can carry on with something else. So that tech support, I think, is an element that cannot be overstated in its importance. I've dealt with a brand that I won't mention that required email questions, and answers were between 24 and 72 hours after, and I just can't deal with that 100%. That I would not use that brand again, because professionally I can't deal with that sort of a delay. In terms of the reputation of the brand, which you mentioned, do you consider this as well when someone's applying to be a distributor as a a wholesaler, maybe a tuning shop is what I'm really talking about? Do you sort of vet your potential tuning shops based on their skill? And why I say this is, it's very easy, unfortunately, the world we live in, which is why HPA exists, is that the majority of tuners, unfortunately, in my experience, do an absolutely horrible job, and they blow up engines, produce cars that drive horribly, don't make the power they could potentially, and a whole raft of other things we already all know about. And the problem with that is that from the consumer's perspective, often the blame ends up lying or getting pointed at the ECU, not the tuner. So in terms of brand reputation and protecting that, what's your strategy for making sure that you are actually dealing with tuners who know what an air fuel ratio is, for want of a better term?
Yeah, and that's a tough one, because that's one of the things I'm looking to change, especially, we've got a new ECU that's going to due out actually in a couple of weeks. And, I'm going to implement a training requirement for that, just because it's too complex a device. Our ECUs so far, the EMU Classic, the EMU Black, really, they're not that challenging to tune and get the basics out of. They're pretty intuitive. There's nothing, out of left field. The strategies are pretty straightforward. But yeah, as we move forward and the products get more complex, I think the most I can do as a distributor is implement a training requirement.
What's that going to look like?
Either in person, or we'll do some modules online with, some questionnaires and some videos, just to, expect them to sit down and watch a module, get some information out of it, and then we'll have a couple of simple questions just to make sure that they actually watched it and paid attention. But we just have to make sure that people are familiar with the product. It's not necessarily my job to teach tuning fundamentals. That's not, I expect people to have a baseline of information there, but as far as getting their familiarity with our control strategies and where things are located, how to use the tools and the software, that's more what I'm aiming at, is just making sure there's a baseline amount of knowledge there at each company that sells our products. And so that's something I'd like to implement in the near future. I'm still trying to figure out exactly how best to do that, because it's a slippery slope. I want it to be, a little bit of a stretch for them to commit some time to learning it, to be good representatives of the brand. But
Of course, you put enough barriers in the way, though, and they're just going to not deal with the brand in the first place. So, yeah, I understand. There's a balancing act here.
And ultimately, I can't control, I don't know who somebody's going to go pay to tune their car, right? They could buy an ECU from a good distributor, but that doesn't mean they're going to tune it, right? They might tune it themselves, or their buddy's cousin's friend's uncle, or some guy that, it's the last of the car on the dyno on a Friday. He gets 3 pulls and kicks it off and sends it to the track over the weekend, and it blows up. Right? I mean, there's any number of scenarios, and I've seen enough work from tuners that who knows what they were handed or where they were at in the tuning process. It's not often I can convince them to give me the final calibration file that they worked on, and for me to vet that, because I just we don't have the resources to do that. So ultimately, there's always going to be the possibility, which is where you really need to do your own work to vet your tuner and find somebody who is well respected in the community, who is can talk to them, say, hey, what happens if there's an issue on the dyno? Are you going to rush the tune, or do I need to buy more time from you? What does this look like? And ask them a couple of really clear questions, make sure that they're going to take the time to get your car right. If obviously you've invested a lot of money and time into it.
And I think these days, the advent of social media is a blessing and a curse, but between social media and forums, there's a lot more visibility around the quality of tunes work that certain shops are putting out. So, for an enthusiast, it shouldn't be too difficult to do a little bit of background research and kind of get a sense of, is the shop that I'm considering giving my pride and joy and thousands of dollars potentially to actually, have they got the runs on the board to get the results that I want or not? Going a little deeper, and not specifically on the ECUMaster brand, but I got my start probably show my age now, probably upwards of 20 years ago now. And let's be honest, it was a simpler time back then. We didn't have CAN bus, we didn't have drive-by-wire throttle, continuously variable cam control wasn't a thing. So, in reality, the tune, particularly on a naturally aspirated motor, it's not that difficult. These days, there's a lot more complexities and technologies that have been applied to our current crop of performance engines. How have you seen that as a problem for those in the tuning industry, basically upskilling and staying on top of this technology so they can still do a good job?
Yeah, the trick is realizing that a lot of your tuners still have a fixed amount of time to tune a vehicle, right? And so I've really pushed the guys at ECUmaster very, very hard, and they've responded with some really brilliant tools in the software. And in the PMU Black and Classic, there's an auto tune feature for drive-by-wire, where it does all of the PID calibration for the throttle by itself. Like, as soon as you wire it up, and it basically checks to make sure that your wiring is good, it does a full sweep and dials in all of its own PIDs that, in my experience, haven't required much, if any, like touching up. The EMU Pro is going to be the same way, already is, and then they've applied that in the Pro also to variable cam tuning, that it'll automatically recognize the trigger pattern, it'll do a full sweep, and then all the tuner has to do is make sure it's tracking, just verify and validate that it is doing what you told it to do, and then make a sweep on the dyno and find peak power. But we shouldn't be manually tuning PID loops in 2023.
I think that PID control tuning is one of the areas that most tuners struggle with. And for those who aren't aware, PID control, it's a proportional, integral, and derivative gains. I won't go too deep into it, but essentially a control algorithm that's used for any closed loop strategy. So you've mentioned there variable valve timing, you've mentioned drive-by-wire throttle. It's even applied to closed loop fuel control and absolutely to boost control, idle speed control. So it's something that's inherent in a lot of the functionality in the ECUs, but if you don't understand how those three gains interact with each other and a specific process for dialing them in, it's very easy to get yourself so far out of the ballpark that you can't even see your way back. And with boost control, that's problematic and could be dangerous, because you can end up with oscillating boost or massive overshoots past your target. So obviously we don't want that. Idle speed may be less of an issue, maybe an oscillating idle. But when we're talking about drive-by-wire throttle, we 100% absolutely want that rock solid, because the driver's foot pedal position could be at X, and if the PID is out of the ballpark, the actual throttle opening at the engine could be something completely different, which we don't really need to sort of draw out the conclusion of what that could result in. So I think that's really smart and simplifies that whole setup procedure. I think most current tuners have dealt with drive-by-wire throttle or variable valve timing. If they had that setup functionality done automatically in the background and didn't need to manually do it, then the actual tuning process of those elements is relatively straightforward. So that's a breath of fresh air. I've definitely used the auto calibration of the PID for e-throttle, drive-by-wire throttle on the ECUmaster product on one of our test cars, and must admit I found it to be absolutely faultless. It was perfect. In terms of other functionality, when you're sort of dealing with bringing functions into an ECU, and this really comes back to the time frame that is available for the tuner to do the work, plus I guess also the average skill level of industry tuners. There's a tightrope that has to be walked. I would always love a function that is really in-depth and allows me to get a perfect result. But if it needs 45 different inputs set up into it by the tuner before it can work properly, that becomes untenable. And it's one of those garbage in, garbage out situations. If the tuner has to add all of these inputs and they get them all wrong, then the function is never going to work properly. So where I'm getting to with this is, as far as ECUmaster are concerned, how do you walk that tightrope when you're deciding how complex to make an ECU in order to enable it to do a really, really good job versus keeping it simple enough for the average Joe tuner to be able to actually calibrate it in the first place?
Yeah, and that's a tightrope every ECU company has to walk, right? Everybody has to make that choice. We just did EMU Pro training for all the the global distributors, and so all the developers on the project presented different parts of the ECU, and the boost control strategy was really beautiful. But I said, look, guys, nobody's gonna have time to tune this, right? If you're looking at a simple drift car, you can say, oh, I need 1 bar of boost, right? And so if you have all these tables and 3D tables need to be dialed and all this, they're not gonna have the dyno time to do that. So you'd be better served to have just a simpler option where you click basic control, and then all those tables disappear. And you got a simple, duty cycle with a target, whatever it is, you could dumb down the strategy for somebody who doesn't need the complexity. Same with closed loop, gearbox control, that they went really, really deep on all the details, and they realized, well, okay, like it's going to take so much testing to get this perfect that can we go 85% of the way and get, like maybe half the tuning time, you can get 85-90% of the results. It's a balance. How much memory do you want to chew up in the ECU to make all those tables for a strategy that maybe not everybody uses? So it's always going to be an argument and a battle to figure out what the customer needs best and what they realistically have time to dial in.
Yeah, it just sort of comes back to the 80-20 rule. You're going to get 80% of the result with 20% of the effort, and then progressively you get smaller and smaller iterative improvements beyond that. So yeah, that balancing it. Now, I also want to come back as well, just talking about these more advanced functions. And again, this is probably more directed at tuning shops who are listening, or those maybe looking at going into that. It's difficult to figure out how to price your work. I know a lot of tuning shops will do an hourly rate, which I've never agreed with. And the reason for that is simply because as you get better at tuning, you're able to do the same job in a quicker amount of time. So if you're charging on an hourly rate, you're sort of shooting yourself in the foot, because the better you get, the less money you make, other than the fact you can maybe turn over more cars. But more along the lines of how we did it through my old shop was a fixed price for an initial tune. And we would never touch up other people's tunes, and that's important to touch on as well. The reason we didn't do that wasn't so we could make more money, but if you're assuming, and almost always it's going to be incorrect, that the last person who touched that car knew what they were doing and did a good job, there's very, very likely, more often than not, going to be baked in errors in the mapping, the calibration that you don't initially see. So we'd always start with a blank sheet of paper, treat it like a fresh tune the car from start to finish, and that was X amount of dollars. Now, after that, if the customer came back in 6 months' time and maybe they'd changed injectors or a downpipe or whatever, at that point, yeah, we're going to do an hourly rate because we've already got them as a customer. That's the only way we could see that it made sense. However, we would also do add-on packages. So it's X dollars for a basic tune, and there's no point in me mentioning that number because it's going to be different depending where you are in the world, but it's X dollars for your basic tune. You've got a cam control engine. Well, we're going to add X dollars on top of that base price. Closed loop knock control, as we already mentioned, takes time to set up. That's going to cost you X as well. And then there was things like, for calibrating closed loop gear shift control for a sequential or paddle shifted gearbox. I mean, that can take almost as much time as the entire other part of the calibration. So,
and you have to make a trip to the racetrack to do it properly as well, right?
Exactly. Yeah, very, very difficult, if not impossible, to do that thoroughly on the dyno. So, just these add-ons, and it means it's very clear as well. There's a lot of transparency between the shop and the customer. No one feels like they're getting taken for a ride. They know at the outset exactly what they're dealing with. So, I mean, it might not work for everyone, but I just want to mention that that's how we used to deal with that. Now, coming back to the development of the ECUmaster ECUs and the functionality, I'm interested because I've used probably just about every brand of ECU out there over the years. And consistently what I find is I get a brand of ECU and I find that they do one particular element of the tuning strategy just super well. Like it's awesome. It's like the best I've ever seen. And then there'll be another element and you're like shaking your head like, what? Who has anyone ever tested this? Like, why are you doing this? And that's, I mean, I'm taking extremes here, but kind of basically what I'm saying is, look, I could cherry pick elements of 5 or 6 different ECUs, and I'm like, why doesn't someone just get all of these, package them together, tie a big old bow around it, and put that out, and I'd buy that in a heartbeat. Of course, my desire list or preferred list of features may not match everyone, but I think the same could be said. Where I'm going with this is, do ECUMaster as a company do sort of in-depth testing on other brands to get a feel for like, oh, this brand does this function really well, maybe we should consider going in this direction? Because collectively I don't see that from other ECU brands. It's almost like they put their blinkers on and like, no, we're not going to look at the competition, we're going down this path, and if people don't like it, then too bad.
Yeah, I think it's a mark of, I mean, what Fortune 500 company would release a product without benchmarking their competitors, right? I mean, it's just something like none of them would invest the time to do a control strategy without looking at what else is available in the market. So certainly, like the guys at ECUMaster Quarters, I know they've taken a look at a few different products, and certainly, if not directly themselves, most of their distributors sell more than one or work on more than one. Like you said, living in a smaller market, these guys in smaller countries in Europe, they can't only tune one brand of ECU and make a living. They just can't. And so they'll take back their feedback. So, hey, this, I worked on this brand, and the closed loop on the XYZ was really great, or idle control was super easy to get dialed in, or hey, this acceleration enrichment model was flawless and took less time to set up. So I think it's a mark of a good company that takes that feedback and tries to implement it. It is funny though. I mean, you talk to guys who tune a lot of one ECU and you ask them, hey, I turned this feature on, it didn't work quite like how I was like, oh yeah, we never use that. Just turn it off. Just don't and I think I think every ECU company has something like that. And I'm not going to throw anyone under the bus because everybody has at least a couple of skeletons in their closet. But there's just some stuff that ends up in some people's software that is just there and kind of nobody really uses it, and you try it and you get frustrated and you just turn it off and ignore it and pretend it's not there. But as we get more and more modern, I think all the brands are really doing a good job right now, and it's a fun time to be in the market because everybody's really competitive and stuff's rolling out faster than it ever has with really great features and better ease of use, and it's just a fun time to watch this market.
Yeah, I 100% agree. I don't think I've come across a brand these days that's still active where I'd say it's a bad product. There's levels to this. And I mean, the other thing we need to consider is that there are ECU brands that kind of target themselves, because it's always a price point issue. So there's brands that will target themselves towards the entry-level enthusiast or club-level motorsport market. And then there's other brands that are targeting themselves more towards the upper level, sort of semi-professional, professional motorsport at a different price point. So obviously the feature set and functionality is going to differ between those, which is fine. But I would say, the modern crop of ECUs, there's nothing out there that I'd say is really terrible. Many years ago when I got started, and I kind of mentioned the time frame there earlier, there were some products that I've tuned, and I won't name names, but I literally just made a blanket statement like, no, we don't tune these at my shop. I'm sorry, you'll have to go somewhere else. Because A, I would waste too much time trying to get a result, and B, I didn't trust that the result I got was going to be reliable for the customer in the long run. And again, this comes back down to protecting your reputation as a tuner as well. If you tune the car and it blows up in 2 weeks' time, unfortunately, the finger gets pointed at the tuner. You get the bad reputation, and that customer tells all of their friends or bags you on forums. So you got to look at the long term or the short term hit of not making that X dollars on the tune is going to protect your reputation and make you a hell of a lot more money in the long run. So that's really important from my perspective. Talking about the sort of changes in technology in ECUs that you've seen over that span of years that you've been involved, what would you say are some of the highlights that you've seen being incorporated that our modern crop of ECUs have?
I think a lot more people, they're including more hardware in the ECU. It's less than, well, some brands accepted. Like some of these installations look like a Radio Shack garage sale where it's just a whole firewall full of boxes. And I get a lot of that comes from a company growing, and as they designed the ECU, it didn't have certain hardware in it, and they had to resort to an external module to add certain functionality. But we're seeing, especially the ECUmaster stuff, more and more stuff included where you don't need 3 or 4 or 5 extra modules to do certain functionalities. So we're seeing more hardware included. We saw a lot of companies kind of go toward like bespoke plug-in ECUs, and now like some are getting away from that.
Let's talk about that for a moment, because that's been a big shift. I 100% agree. And again, looking back at those cars I referred to at the start of my career, really quite basic, no CAN bus, mostly either a manual transmission or a very basic electronically controlled auto transmission. It was really easy in those days for most ECU manufacturers to kind of take their base standalone ECU board, kind of repackage it with the ECU header plug for the vehicle, and kind of call it a plug and play. And the turnaround time on some of these products was literally a few months. These days, not as easy / almost in some instances impossible, with the advent of multiple control modules in a vehicle, DCT, DSG gearboxes, and also CAN bus communication between these. So I've kind of seen that shift away from plug and play solutions, which is really frustrating, because for the customer's perspective, plug and play is amazing. It's just so simple and easy. What's the complexities? Why are ECU manufacturers sort of veering away from that? And is there any sort of light at the end of the tunnel for these current crop of cars?
And so one thing I've seen is, like you said, a lot of people repackaged the board and stuffed it in kind of an OEM style fitment. And, ECUmaster from the beginning, we just did plug and play adapters, which I like, because they're a little bulkier, but our ECUs were small enough that the current crop ECUs are small enough. It's not a packaging problem. And then if you do go to a full engine harness later, you want to build a nicer harness, you don't have to buy a new ECU or revert to using the factory header. So if you're wiring in extra inputs, you don't have to use an auxiliary connector. There's some other things that I like about it. And then, ECUmaster has made a few plug-in ECUs just for certain packaging requirements, locations where you needed a different form factor. But, more and more now we're seeing, shift back toward plug and play adapters versus a plug-in fitment. But you're right. I mean, the amount of integration in modern cars is really overwhelming, and you have to get that money back on the R&D by charging a higher price, because it can take, so much time to reverse engineer the CAN bus on this stuff. And then make a bespoke product for that application.
I just wanted to interrupt our chat with Zach for a moment and talk about a course that I think you'll really like if you're enjoying our chat with Zach, and particularly if you're considering using the ECUmaster brand, or maybe you already are, and that is our practical standalone tuning course. This course is, in essence, a generic course that will teach you how to tune any aftermarket standalone ECU, and that is because, irrespective of the user interface and idiosyncrasies between different manufacturers, essentially the way an aftermarket ECU works is broadly the same across all of the different brands. This means if we understand the basics, we can apply this irrespective of the specific brand. Particularly in this course, we break down the entire tuning process into the HPA 10-step process. And by doing this, each of those individual steps is relatively quick and easy to complete, and in no time we've got a completely tuned engine that's delivering great power, great torque, great drivability and fuel economy, and most importantly, great engine reliability. Once you've gone through the generic part of the course, we dive into our library of worked examples, and in this library we vary both the engine that we're tuning as well as the type of ECU we are using. And specifically within that worked example library, we do have an ECUmaster EMU black worked example. I alluded to this in our introduction. We fitted this to our version 11 Subaru STI. You'll get to see the entire setup, installation and tuning process being performed in real time. Once you've purchased the course, it is yours for life. You get to watch it as many times as you like, whenever you like. This gives you the benefit of being able to learn from the comfort of your own place, and you can learn at your own pace. And as with all of our courses, we offer a 60-day no questions asked money back guarantee. If you purchase and for any reason at all decide it's not quite what you expected, that's fine. Let us know. We'll give you a full refund of the purchase price. We will put a link to that course in our show notes, and remember, you can also use that coupon code podcast75. That'll get you $75 off the purchase of your very first HPA course. All right, let's get back into our interview now. This is probably a good segue into talking a little bit about CAN bus, because this is so integral to what we've been talking about so far. So can we start with just a super high level understanding of what CAN bus is and why that is problematic in these modern cars?
Yeah, so CAN bus is just it's a network. It's like plugging in your computer to your home network if you're using a wired network, and it's for different modules in the vehicle, not only to send and transmit one-to-one, but they can dump a message on the bus, is what it's called, all the connections between different modules. Any module can dump information on the bus or pull information off the bus. So rather than having to wire each individual signal individually, it's much cleaner that you got two wires for noise rejection to send this bus through the whole vehicle. And there's generally multiple buses depending on what types of functionality there are. But it's just a very easy way for modules to talk to each other. I say easy; it's easy to implement. It's difficult to reverse engineer. It's almost like code breaking to get back into this stuff and figure out what messages they were sending and how they're scaled. And there's a lot of complexity there.
Yeah. So, I mean, the problem comes in that we take a modern car that, let's say it's got an electronically controlled automatic transmission, or DSG for that matter. So it's got a transmission control module. It's probably got an ABS computer. It's probably got another module that controls the gauge cluster, maybe even air conditioning, traction control. All of these can be separate modules, or at least require specific messages to be transmitted on the CAN bus from the engine control module. So obviously in stock form, everything works nicely. As soon as we remove that factory engine control module and wire in an ECUMaster, ECU, or any brand for that matter, natively, those signals now no longer exist. So we could, in most instances, get the engine up and running with little to no trouble, but then driving the car becomes impossible. It's not going to select gear, it's not going to drive, you won't have RPM and speed on your gauge cluster because those messages are interrupted. Now, some manufacturers have sort of dealt with this in a couple of ways. We bring in Motec with their M1 platform. They've got two ways of dealing with this. They do their own in-house plug-and-play solutions, again with adapter harnesses like you've mentioned, and basically they will reverse engineer those factory CAN messages, figure out what is needed, and then implement those on the M1 platform. And then you've got a plug and play solution. Likewise, they've got a dealer network that they provide the tools inside of their ECU to allow smart enough developers to do the same thing. How are ECUMaster dealing with these modern vehicles, or is integration at that level not something that you're targeting?
Again, just like the other control strategies, it's a balancing act, because you can get into a lot of the more advanced CAN bus functions require the tool it would take to implement on the user end would require so much memory in the ECU. It becomes a balancing act of how many resources do we want to commit to a tool to do this, or is it easier for a dealer or distributor to reach out to us directly, give us the CAN data, we implement it, and then put it in as part of a package. And ECUMaster is a little unique that there's no charge for extra features or unlocks. You get the product, it's yours. There's nothing else to unlock.
So as it continues to develop and you get more CAN templates for more vehicles, that's just a firmware update.
Correct. And that's the same way it's been with all of our products so far. And with the Pro, we've had discussions, and this is still being implemented, where there will be a level of password protection for just CAN bus functions, to where someone who wants to make a package, let's say some new, motorcycle or side-by-side or car comes out and there's a lot of CAN bus integration, someone sorts all that out, writes all of their CAN bus IO in their own software. They can lock down that portion and sell a plug-and-play kit to a customer that says, hey, the CAN bus stuff is sorted out. You can do the mapping yourself. Anything else you can touch. But, what I've invested my time into reverse engineering and getting sorted, you can't touch that. But I'll sell you the ECU, and I get to make, whatever money I make on selling the ECU and the adapter harness. And that's a great business model, because nobody's headquarters has enough resources to CAN bus reverse engineer every vehicle on the planet, but there's a really decided advantage in a shop that specializes in one platform to come up with their own solution that nobody else can have access to. They can sell to their customers, or then sell in bulk and justify the engineering time invested.
Yeah, I mean, it can take days, if not weeks, maybe even months to properly reverse engineer a CAN bus, particularly on the more complicated vehicles, and then go through the testing procedures to make sure that works. So, I mean, obviously you're not going to do that and sell one unit and then have that template ripped off. So the ability to do that is unique, which sort of kind of brings me to the other element is, as I've seen it with the ECUs I deal with, the way ECUs deal with CAN buses is kind of very much one or the other technique. One technique is that it's very locked down, and you get to select your CAN template from a drop-down menu, and if you want to adjust it or maybe add a receive template for maybe I mentioned earlier, a wideband controller, maybe a wideband controller that's not natively supported in that drop-down menu, you're on your own. Maybe you could send a request to the ECU manufacturer, but short of that, you're done. That seems probably the more common technique that I see. And then there are a handful of ECUs where that CAN bus capability is very, very open in terms of the user can write their own receive templates, which I'm talking here is receiving information in from the likes of that wideband controller, or maybe from a transmission control module, whatever that may be, and also a send or write template, which is what the ECU is then sending out. So, a simple thing there is if you want to display RPM and coolant temperature on a CAN-enabled gauge cluster, you have to send that data, the engine coolant temperature and the RPM messages. They have to be sent out and scaled correctly so that the gauge cluster can interpret those and display them properly. So that's the two techniques I see. Do you know why it was that ECUmaster decided to go down that more complex direction?
We didn't have the brand equity, right? We're not a 40-year-old legacy ECU company that can tell people to kick rocks, right? You get what you get and you'll like it. And so as kind of the scrappy upstart, I think there was more incentive, when the, EMU Classic and Black were created, we didn't have our own dash display. We didn't have our own power management unit. And so we were obligated to make it work with other people's products and kind of unlock that. And then with the CAN bus stuff, I think it was a relatively easy implementation to set up a basic CAN receiver transmit. And what's in the EMU Black is not wildly complicated, right? You can send basic transmit and receive messages, but we do have a lot of templates for common products, common dash clusters, the E46 base and M3, the FRSBRZ, 350Z, a lot of OEM gauge clusters, cars that are popular for swaps like the RX-8, no offense, rotary guys. But having that functionality as a drop-down is very, very easy to do. And then with the PMU 16, we realized that was a much higher end product. Our entry level, our ECUs are pretty entry level. Nobody's ashamed about that. It's the price point especially. And so the PMU and the ADU were aimed, and the ADU is our dash display. They were aimed at a much higher end demographic where it's going to have to integrate with other people's ECUs, and those customers are going to want to do some custom CAN stuff. So that was the reasoning behind that.
I want to dive into that product, particularly the PMU, in a moment. In terms of that sort of, from what you've just mentioned, CAN integration has become really, really important with modern aftermarket electronics. And one of the pros and cons, I guess you could look at it either way, is that exactly as you're saying there, it no longer means that a user is locked down to one brand of product. So you don't have to have a matching ECU, dash display, power distribution module, wideband CAN module. On CAN, it is a standardized template. So it's not that ECUmaster have come up with this communication template. This is a standard, well-developed, well-understood, well-known protocol. And as long as you stick to that protocol, you can now receive and send messages between competing products.
So long as at least one end of that has configuration.
Yeah, absolutely. We're going to take that as a given. But this kind of, I guess, as a manufacturer, it's a double-edged sword. You kind of allow then your products, such as the PMU 16, to be integrated with other electronics platforms, which is exactly what we're personally doing with our SR86 race car. We use Motec Dash and a Motec ECU, but two PMU 16s. But it means that ECUmaster, how do you work out, like, A, are we going to sell more product as a result of this? Are we going to sell more PMU 16s? Or are we, B, going to actually lose out on ECU sales because we're not going to get the ECU to go along with that?
PMU sales have done great. And we see a lot of people integrating not only with aftermarket ECUs, but in certain classes, you're class limited to a stock ECU, or you're building a resto mod that's going to use a GM crate motor that has a factory ECU. So it's not just, aftermarket ECUs we're competing with, and we're not really competing with it. We're still happy to sell the hardware, right? We're not selling the PMU as a loss leader to get someone to buy an ECU. And so, and granted, there is a level of tech support you have to expect, and that's one of the biggest costs in my business. But I'd rather offer something that more people can use than narrow our market down to force people into one family of electronics, because again, certain classes, certain racing series, the choice of ECU might be totally out of your hands. Maybe use a carburetor, I don't care. But integrating with more products, I think for us has proven pretty valuable.
I don't get to see the numbers in the back ends of all of these ECU manufacturers clearly, but I mean, to me, it makes sense to get more product out there in more platforms. And I mean, people also have their preferences. Maybe they like XYZ brand of dash, a different ECU, and then they can incorporate your PMU because they like that feature set. It just gives that flexibility to mix and match and still make everything work really nicely together.
And there's a few companies making power distribution where they're not truly standalone devices. They're, it's a secondary unit that ties onto an ECU, and that's fine. For their customers, it's a great solution. But ours, from the beginning, was designed as something that could stand by itself in a car with no other electronics to support it. It could still do its job.
Yeah, absolutely. I mean, I'll bring in an example of what you just said there. I've just gone through and filmed a worked example on the Max ECU brand, and they've got that system where they have their own PDM, but it will only work with the Max ECU. The nice feature with that is, in a way, when you're setting up an output that's on the PDM, it's really no different from the user's perspective than setting up a wired output on the ECU. You're using the same software package. Downside, of course, they're not going to sell that to a customer that's got a Haltech or a Link ECU. It's not going to work like that. So, you make your decision, and that's the path you go down. Now, I want to talk about this ECU that you've mentioned a couple of times now that's due for release shortly, the ECUmaster Pro. So, can you give us a little insight? What are we expecting from this? What are the improvements or advancements from the likes of the ECUmaster Black that I've got personal experience with?
Yes, I mean the line of the EMU Pro, they're scratch built. So in the beginning of the company, Jacob, who's the founder of the company, all of the EMU Classic and Black were really 100% programmed by him, and that was kind of his baby. And then as the company grew, we had the ADU come out and the PMU, and more developers came on board that really handled those products exclusively. So he's not been directly involved. He's been obviously managing the company. And then the EMU Pro is a completely separate ECU. It's used a lot of the strategies they perfected in the Black, like I mentioned about, like the drive-by-wire calibration tool. A lot of that code was used for the Pro. Some other stuff, like we've got a lot of control strategies for the DQ250 and DQ500, the front-wheel drive, DSG boxes or DCT. So a lot of that, information was used for it, but the control strategies are a lot more advanced. They're all new. The hardware is different. So yeah, it's just a new family of ECU, and it's more heavily based in the world of the ADU and the PMU. So the software is going to look familiar to someone who's used the PMU or the ADU. Obviously, with an ECU, you have more graphical needs than configuring outputs. You need to have 3D tables more often and have a look at that. But yeah, very sophisticated product. All the strategies kind of get another layer to complexity. Some things that were complex to set up, sometimes setting up acceleration enrichment was really challenging on some motors, or getting idle control to work more fluidly. And so those control strategies are all brand new, where they're more complex, but the actual tuning side of it takes less time, and it's much more robust in the way it handles it. And some of that will be kind of backdated and applied to a new firmware for the EMU Black, as they learn some things with playing around with different control strategies with no requirements for backwards compatibility. And that's another problem we could talk about and have a whole other hour about, is sometimes getting stuck with backwards compatibility needs.
I assume as well you've got a higher I/O count on this Pro product. That was a limitation that I came up against on what was still a reasonably simple engine with the EJ20 that we had in one of our test vehicles, which had quad variable cam control. But essentially, by the time we got drive-by-wire and 4 variable cam control outputs, we've run out of functionality on the Black.
Right, exactly. And that's, we were all well aware of that for a long time, because, you make an ECU and you don't think about every situation, or maybe you're stuck with a certain connector family and you just, or whatever processor you're using doesn't have the headroom for it. So the EMU Pro, there's a Pro 16 and a Pro 8. The Pro 16 has 4 connectors on it. The Pro 8 is just down 1 connector, but all the other pins are identical. So if we make a plug and play kit for a Pro 8 and you run out of IO, you can upgrade to the Pro 16. You have that whole extra connector with more IO on it. Pro 16 refers to the 16 peak hold injector drivers. The Pro 8 has 8 peak hold injector drivers. The 8 has 8 high current ignition drivers. The Pro 16 has 10 high current ignition drivers built in. And you can use 2 auxiliary outputs to do like a 12-cylinder sequential with smart coils.
So you've got a lot of flexibility on what you can actually drive with that. In this day and age with peak and hold injector drivers, I can't actually remember the last time I tuned an engine that had a peak and hold injector. I mean, saturated drive injectors kind of become our go-to now, both in OE and the aftermarket. You obviously still see a requirement to support peak and hold injectors.
Drag racing market.
Okay, yeah, fair.
Yep, there's all these giant garden hoses of injectors that we decided to go and include the drivers for that.
I guess on that basis as well, the 16 channel lends itself really nicely to the likes of a Pro Mod V8 with staged injection, 16 injectors for an 8-cylinder engine. Okay, now I'm interested to dive real briefly into the world of these DSG gearboxes. You mentioned the support that you've got there, and this kind of comes back to our conversation earlier about CAN integration. So I'm guessing here what you've got is a CAN template that's already set up to communicate with the Volkswagen Audi Group transmission control module so that you can swap in a DSG transmission and basically drive that with the ECUmaster product.
Correct.
Is the complexity there from the standpoint of the user? I mean, most of these factory ECUs work on a torque-based model, and at least as I understand it, I haven't really had too much hands-on with this, but the sort of back and forth communication on the bus between the TCM and the engine control module in terms of there's a shift request and the transmission control module then asks the ECU for a torque reduction, waits until it gets a message back saying that torque reduction has been completed, then it'll shift gear and then allow the torque to be ramped in. So how do you work that with a volumetric efficiency based ECU?
Yeah, you do a lot of torque estimation based on airflow, right? So you basically populate a table that is your basically your torque output, and you map it based on that. And then when you get that torque request, it modifies it for that. So it's not a purely torque based ECU, as you know. The EMU Pro will be a little bit more advanced in that regard with basically torque management strategies, just because they are so handy for whatever gearbox you're controlling or for traction control, to not have to go out and really hand tune every part of your traction control strategy. If you already have a pretty good estimation of torque based on airflow on a table that you populate, then that helps quite a bit.
Okay. In terms of estimating torque, obviously, as you mentioned, airflow is a key element of this, but also the ignition timing and where you are relative to MBT timing or maximum brake torque timing, that plays into it. Does the EMU also sort of model that behavior in terms of how far away you are from MBT and the reduction in torque as a result? And I guess this sort of comes down to if you're going to use the likes of an ignition retard or a cut event for torque reduction on an upshift.
Yeah, so there's some ignition retard involved, and I haven't actually hand tuned one of those boxes yet. So I'm not. They're still in beta, and there's a group that's working on it pretty actively. But yeah, it'd be a combination of that, and to a certain point, closing a cut or ignition or closing the throttle.
Okay. However, essentially, in a nutshell, what this is going to allow is the integration of a modern DSG gearbox with all of the advantages that gives to an aftermarket ECU installation, matched with perhaps an engine that was never designed to be backed by a DSG box.
Correct. And yeah, as you know, on the racetrack is one thing. Getting it to drive well in all temperatures and conditions on the street is the fun part. Getting it to take off from stoplights nicely. And so yeah, we've seen a lot of guys implement it well so far, and really most of the firmware revisions that have happened have just been drivability improvements. Getting the basic functionality working was not the harder part of it. We've seen a few people doing different swaps or putting a modern driveline in an older car. That's a popular one. And then eventually we'll get to the rear-wheel drive DSG and DCT stuff with other manufacturers. And then the EMU Pro also will do auto trans control, whether that's an auto trans that has its own ECU in it or controlling the solenoids directly. And then the torque modeling helps quite a bit there for reducing torque on upshifts and managing that.
Yeah, no, it sounds like a sensible direction to be going with the popularity of dual clutch transmissions and obviously the modern automatic transmissions as well. All right, let's move on. Last topic I really want to talk about here is a little bit of a deep dive into the PMU 16, and we stay pretty brand agnostic at HPA. I use and test just about anything that comes across my desk, and I must admit the PMU 16 is one of my standout favorites in the world of power distribution modules. And I wouldn't say it's all singing, all dancing, the best product out there. But what it does really nicely, in my opinion, is it straddles that really fine line between price point and functionality. And at the time we're recording this, I think in the US market, that product comes in a touch under $1,400. So there's still an investment involved, but in terms of the benefits that it brings, I think it's easy to justify. Can you start by giving us sort of a quick overview of what that PMU 16 product actually is and does?
Yeah, so when we say power management unit, we mean controlling electrical power, not engine power. And so it replaces fuses and relays. So you've got 16 output channels, you've got 16 analog input channels that you can use with a sensor or a switch. The outputs are high side. When I say high side, I mean that's supplying 12 volts to an output channel. So if you wire up one of the outputs, it's a single wire to your fuel pump or your fuel injectors or a fan where if you wire in a relay, it's 4 connections minimum, which can get really clumsy and cluttered. And then you still have to have a fuse that's 6 connections or 6 terminations for one output instead of 1 on a PMU. And it can monitor current in real time. So you can basically set digital fuses, if you will, over a certain amount of time. If it exceeds the current, it'll turn off the output. It can send a warning via CAN bus. There's indicator LEDs on the device, but it's just a very sophisticated way to control all of the power outputs and power controls in your vehicle. So if you're familiar with modern vehicles, it's like a programmable body control module. It's going to drive all the electricals in the car.
Now, we won't go super deep on what the advantages of the PMU are beyond what you've just mentioned, because most people probably have a bit of a broad idea. The electronic fusing and the ability to retry a particular circuit a number of times are really important. I think when people are considering the electronics package for their car, the price point, even at $1,400 can be something that is a stumbling block for a lot of people, particularly if it's maybe there's not a massive budget to throw at the car and you've got to focus where you're going to put that money. I'll admit it's not for everyone, but I think it's also really important to factor in the cost savings, which is easy to overlook. As you mentioned before, relays and fuses. There's a cost involved with those relays, there's a cost involved with the fuses, but the more important element is on a reasonably complex installation, there's a lot of hours if you're paying for labor that go into actually doing a nice job of wiring up and mounting fuses, relays, and switches, whereas the PMU kind of gets away with all of that. So the actual complexity and time involved in the wiring installation is dramatically reduced. Specifically as well, because you then can get away from switches. Hey, if you want old mechanical switches, absolutely fill your boots, you can still do that, but most people are really integrating these with CAN switch pads, which means you've got the ability to have multiple inputs via a 4-wire connector, power earth, CAN high and CAN low. So that's the basis of it. One of the objections I've heard with the PMU 16, and I mean, I guess ultimately we've come up against this, I should say, ourselves, is, as its name suggests, it's a 16-channel output. So probably not too bad if you're doing a very simple installation. But if you want to start doing complete body control as well as ECU control, power supply for your engine side of things, that can be a limiting factor. Is the intention to bring out higher output count versions, or is there a reason why ECUmaster have stuck to 16-channel?
So it's funny you mentioned that. We have the PMU 24 coming out in about a month and a half.
Okay. Objection answered.
Yeah, so that'll add 8 additional outputs that are 7 amp. There's a lot of body control functions that just don't require a lot of current output. LED lights, indicators, headlights, taillights. If it's all LED, it requires almost nothing. And so it's going to be visually almost identical to the PMU 16. What would be 8 analog inputs, they're actually multiplexed. So if you need 16 inputs, I don't know why you'd buy a PMU 24 if you're only going to use 16 outputs, but if you need to multiplex 1 or 2 of the outputs as inputs, you can multiplex. Multiplex means that you can use the same terminal as an output or an input.
Right.
You can
Smart.
basically assign the function of the terminal to something different, which you can do some of that in the Pro 16 and Pro 8 as well, which is clever. But yeah, so 8 additional 7 amp outputs plus the 6 to 15 amp and 10, 25 amp. You can pair up to 3 outputs together if you need up to 75 amps per output. Physically, it's the same form factor as the PMU 16. It just has another row of LEDs for indicators for the status of that output channel.
What I will mention as well is both the EMU Black and the PMU 16 tiny footprint. Might not seem meaningful, but makes it a lot easier to actually find space to locate these products. The other thing I mentioned as well, I mean, I don't see 16 channel as necessarily a disadvantage. What that can do is give you the flexibility as well to mount maybe one of the units. If you've got a lot of stuff going on at the rear, maybe multiple fuel pumps, maybe transmission coolers, diff coolers, tail lights, etc., or you can simply mount that particular PMU at the rear of the car, saving you on your wiring runs as well. Then all you've got is CAN communication and the main power feed to it. So upside there, upside, downside, I don't know, just really depends on your installation. Talking about some of the functionality, obviously the 16 output channels with different current capabilities, I think 25 amp and 8 amp if I'm remembering correctly, which
25 and 15. 25
and 15, I apologize. So this brings me to one of my, I'm going to say it's one of my dislikes of the product, which is the connector. And I mean, hey, there's nothing specifically wrong with it in most installations, but when I was doing the harness for our 8.6, it was a fully sealed mil-spec style of harness, and it's not a connector that lends itself particularly well to a back shell and booting, albeit I know we've had particularly one guest on from motorsport levels, motorsport wiring, I think it was, who does a really nice job of this, and it was after I'd already built my harness. But what is it that drove ECUMaster to go with that particular connector?
So it's a connector we already have familiarity with from the EMU Black. So they knew the capabilities of the connector. The larger terminals on that connector, when you make them out of the right material, the right metal, they will withstand 25 amps continuous.
So that's quite uncommon in PDM world. Quite often, I mean, there's no fixed sort of, this is the connector everyone uses, but I would say the Super Seal 1.0 connector is probably the more common. And of course, on those, you're limited to a 20 gauge wire, and about 7-8 amps is about as much as you're going to get through one of those, correct?
Correct. And so we had custom terminals made that go down to, I think, a 12 gauge wire in one of the 25 amp terminals out of a unique alloy that'll withstand the temperature. And so it was more reducing the number of splices and giving you the flexibility to choose wire gauge. People also don't realize that the PMU does shed, it's a CNC aluminum housing, it does shed heat through the device itself, but the wires you connect to it as well, like not only do they have to transmit current, but they're also used as a heat sink. If you look at, if you put a FLIR camera or a thermal imager on the PMU, your actual harness is a good heat sink as well for the device.
Yeah. So it saves basically pairing everything together. But of course, if you do want to go above 25 amps for some reason, and I can't think of too many options, you can pair them up anyway if you want to. One of the nice functions, and it's definitely not something that ECUMaster have all to their own, but the ability to pulse width modulate an output for speed control. That's reasonably uncommon in the power distribution module world. So what advantages does that give to the end user?
It's, so if you don't want to run, nobody ever thinks about where, and it wasn't until I studied thermodynamics in engineering school that I kind of thought about where does all the heat go. So if you're running 50, 70 amps of fuel pumps full time, they're just little heaters, right? All that energy is going into the fuel or into the fuel tank, right? Depending if your fuel pumps are submersed or not. And so running them at a lower duty cycle, right? Not running them full speed all the time. If you're just butting around, you don't need 3 fuel pumps running. So we're all familiar with switching them on. Back in the old days, it was with a Hobbs switch, with whatever you wanted to use to control it, but also running them not at full speed. OEMs do this and have done this for a very long time. So having the ability to do that within the PMU is really nice.
I've tried this myself, and I actually did come across a bit of a problem, and it's not an ECUMaster problem. This is just an element of pulse width modulating the speed, or for speed control, is that it does create a fair bit of heat in the transistor on the board. And where I came up against this was attempting to use pulse width modulation to control the speed of an electric water pump, which is our Davies Craig electric water pump. And basically I came across a problem where it'd run for a certain amount of time, and then it would just go into an overheat shutdown to protect the PMU unit. Now, in ECUMaster's defense, this is documented in the manual, so it's not something I necessarily wasn't expecting. But what causes that problem, and what is the solution around pulse width modulation control without this overheating problem?
Yeah, so it's really a sliding scale. The higher the inductive load and the higher the frequency you want to control at pulse width, the more flyback energy effectively you're dumping back into the device. So the solution there is to use an external flyback diode to handle the flyback. So the higher the frequency and the higher the load, the more you're going to need kind of thermal management by putting the flyback diode outside the device.
Okay. Now, not only does it allow pulse width modulation, but you've also got the ability to get some quite sophisticated control over the way a output is powered up. So, for example, if we power up a fan and we look at the current draw of that fan instantly, what we'll see is what's called an inrush current. So maybe it's going to have 10 amps continuous once it's actually up to speed and operating, but that inrush current could hit maybe 40 or maybe 50 amps. And it was only for a couple of hundred milliseconds, so not necessarily a problem. First of all, the PMU actually provides the ability to protect for that inrush current while still providing protection for the continuous operational current draw as well.
Yeah, and it's really fun to play with because you can monitor current in real time, and you can dial it in until it's just a dead flat line of whatever limit you set. And the benefits there are, if your injector data is not quite perfect, anytime you drop voltage or voltage swings by heat, imagine you're doing a full throttle pull and your voltage drops because both fans kick on or whatever the case, and you get into a spot where your injector calibration isn't quite correct, and it could alter your fueling or reduces the power available to your ignition coils. You have a misfire because of it if your system's on the ragged edge. So being able to soft start that and ramp it in, it's just better for everything. everything lives a little bit happier, that you don't have that huge dip in voltage or that big spike in current through the fan.
So that soft start functionality, if we turn those fans on, rather than just instantly it's off and then all of a sudden you've got full battery voltage supplied to the fan, which results in that massive inrush current, we can just bring that, basically, it's essentially pulse width modulation for a very short period of time to bring that fan up to speed and avoid that inrush current.
I really don't recommend for most people to try to speed control a fan. If you look at a factory fan controller, look at the size of the heatsink on that thing. That's what they're doing. I mean, they're managing a ton of thermal energy, but soft starting it's just that split second. It's not going to damage the PMU. And the PMUs, all three variants we have of it, they have 3 temperature sensors on the board, so you can monitor the temperature and make sure you're balancing the load across the device if you need to shift outputs around.
Yep, perfect. And also, I will mention my dislike of the connector, and it's a bit tongue-in-cheek. I mean, it's a personal preference here. However, if you really do have a problem with that connector, you also offer an Autosport connector variant as well.
It's gorgeous. Yeah, I love the Autosport version. So in my personal 350Z drift car, we have an Autosport in the engine bay where the environmental requirements a little bit higher. And I wanted those really nice connectors that are sealed. And then in the back of the vehicle, I've got a second, just regular PMU that doesn't need the additional environmental protection. So yeah, and the PMU Autosport also has 6 low side outputs that are, I think, rated to 1.5, 2 amps. And it's neat because you can use one high side to power all the lights and then trigger your blinkers and your tail lights with all the low side outputs. So you can still have, current monitoring and protection on that, but have all the control through the device still.
So just again, to come back, you mentioned high side, and that's switching to 12 volts, switching the output high to 12 volts. So a low side allows you to switch to ground. So you would have a permanent power connected to the other side of whatever you're trying to drive in that instance.
Or power it from one of the outputs from the PMU.
Correct. Yeah. All right. Zach, we're going to have to move on towards wrapping this thing up, and we're going to finish with the same 3 questions we ask all of our guests. The first of those, what's next in the future for you? ECUMaster USA, ECUMaster International. Give us some insight.
Yeah, the big thing, the guys in Poland, they're prepared for more growth. They've already got, they built a beautiful facility and factory that, they're using now. They're doing their PCB assembly in-house, which is really unique, brand new assembly line. I mean, it's really, really gorgeous. So, and they've got room for expansion. They're going to, build more of their building to expand operations there. They've been hiring like crazy. For us stateside, my company is called Wholesale Horsepower. We do run, we are ECUMaster USA, and we represent 2 other brands. We represent Verkline, which is another Polish brand. They make tubular subframes, billet uprights, control arms that allow you to change the kinematics of a race car and shed weight and get more adjustability. It's been really great working with them. We're getting their brand more recognized in North America. And we also represent ZRP. They're a Greek company that makes crankshafts and connecting rods. So my company, we moved into a new building to us last year. So we're just expanding there. We're going to make more media, more videos showcasing our products and explaining to people how to install them and use them and make it more user-friendly. And the guys in Poland are continuing with the EMU Pro platform. We've got a lot of work there to train people and get it all fleshed out and get into a bunch of race cars and grow that. And exciting few years ahead.
Yeah, it sounds like exciting times for sure. Growing is always exciting. Next question, Zach, is there any advice you'd give to a younger version of yourself or one of our listeners to maybe fast track your career and get you to where you've got to faster? You've sort of sound like you've had a fairly roundabout route to get to where you are now.
Yeah, and always find somebody you can ask questions, right? Find someone you look up to that has a skill set that you don't. I had this conversation with someone else in the industry yesterday, and he kind of commiserated that it's tough for him to find somebody at this point in his career that has answers that he doesn't have. And so, earlier in your career, it's a lot easier, but find somebody you look up to, and, you're always going to see the good and bad in their business if you work for them, but pick out the good and learn from it and store that away. Never hesitate to learn a skill set. Spend $200 on the welding class at your local community college, right? Put those tools in your tool belt. It's never going to hurt you to have these skills. If you're going to ruin a car, make it your own car, right? and I've got a Supra sitting in my shop I've owned since I was, 17 years old. And it has a lot of my past mistakes in it that I need to go back and clean up. But I'd rather do that on my own car and build the skill set than take money from somebody in good faith for something that I haven't learned on my own, right? That's a very good thing to have your own test bed and,
Yeah, I think a lot can be said for that, and that's always been my advice as well. We obviously always get asked, how should I get started as a professional tuner? And my advice has always been the same, get your own car, buy something that you can tinker with and start honing and refining those skill sets on your own platform, because when you're starting learning on customers' cars, you're opening yourself up for some potential pitfalls, and that often can end up impacting you on your reputation and your career progress too.
100%. Just to throw a plug in for Formula SAE as well, or Formula or SAE Baja, you do not have to be an engineering major to participate. And not many people know that. They need people to run the business side of it. They need people to do purchasing, to do sponsorships. No matter what you're studying in school, go find your local SAE chapter. And if you want to get involved, right? They'll let you do as much as possible, but do not hesitate. So if you do have that program available at your school, see how you can get involved and help them and learn anything you can for sure.
Yeah. And again, as we mentioned earlier, I think, that Formula SAE being involved has just become such a consistent element of the people that we talk to on this podcast. I couldn't say enough good things about the opportunity I never had to get involved with.
Don't mean to rub it in.
Yeah, I'll take that to my grave. Not sad at all. Last question for today, Zach. If people want to follow you and find out more about what you're up to and the ECUMaster product, how are they best to do so? What are your sort of social media accounts?
Yeah, so obviously ECUmaster USA. There's no S on the end of ECUmaster. That is a personal pet peeve. So yeah, if you look for ECUmasters USA, you're not going to find it. It's ECUmaster USA. You can follow the ECUmaster headquarters social medias, Verkline USA, ZRP USA. We've got socials up for all of them. Myself personally, you probably don't want to follow my account. It's really just like half car pictures, half cat pictures. If you like cats, then go for it. But yeah, it's holy sacrilege. So yeah.
Easy to find. Well, I'll tell you what, we'll make it super easy by putting all of those links in the show notes so that people can't spell it wrong. Well, look, great to have a chat, Zach. It's been a while since we've caught up in person, so good to see you on the pod, and we really appreciate your time today. All the best for the future.
Thank you so much.
If you enjoyed this episode of Tuned In with Zach, we'd love it if you could drop a review on your chosen podcasting platform. These reviews really help us to grow our audience, and that in turn helps us to continue to get more high quality guests. To say thanks, each week we'll be picking a reviewer at random and sending them out an HPA t-shirt free of charge anywhere in the world. Also, this is a great place to ask any questions you might have too, and I'll do my best to answer them if your review gets picked. So this week, a big shout out to Drive Performance from the United States, who has said, great podcast. If you like the technical side of motorsports, this is the place. Possibly the only podcast and YouTube channel like it. Keep up the good work, Andre and HP Academy. Oh, thanks for the kind words. Glad that you're enjoying the podcast. And if you reach out with your t-shirt size and shipping details, we'll fire a fresh tee off straight out to you. All right, that concludes our interview. And before we sign off, I just wanted to mention for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis, and race driver education. Now remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our Gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a Gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.